Hello, welcome to Business Statistics. In this lecture, I will talk about comparison of two population means. I will talk about known variances. That is, we would know the population variances. So we will be using Z statistics. Suppose we have two populations. So this is population 1 and the mean of this population is represented by mu1, and we have population 2 and the mean of this population 2 is represented by mu2. So we would be interested in knowing whether mu1 is different from mu2. That is, mu1 is not equal to mu2, or we would be interested in knowing whether mu1 is greater than mu2, or we would be interested in knowing whether mu1 is less than mu2. So you might know that mu1 not equal to mu2, this is mostly a two-tailed test, and because it in two-tailed test it's directionless, so we can disprove we can prove on both sides the alternative hypothesis. Mu1 greater than mu2 and mu1 less than mu2, so these two are one-tailed test because we are testing on only one side. So these can also be written as the difference. So like mu1 minus mu2 not equal to 0, this can be written as mu1 minus mu2 greater than 0, and this can be written as mu1 minus mu2 less than 0. So to compare both of these populations, population has a bigger set, or they consist of all the elements. It's difficult to get the facts about the population. So we can take a sample. So if this is a sample from population 1, so we take sample 1. So the facts about the sample would be represented by x1 bar is the mean of the sample. So this is x1 bar. x1 bar. and the standard deviation of the sample can be represented by S1, and the sample size can be represented by N1. Similarly, if we take a sample from population 2, so this is sample 2, and the facts about the sample 2 or the statistics are represented by x2 bar, and S2 is the sample standard deviation, and N2. So one of the things is we have mu1 minus mu2 on all the three cases. So as we learned previously that x1 bar can be used as an estimator for mu1. So sample mean can be used as an estimator for population mean. Similarly, in this case, x2 bar can be used as an estimator for mu2. So we can kind of say x1 bar minus x2 bar, which is the difference of the sample means, can be an estimator for the population difference. So estimator for population difference. So if the sample size which we take is large enough, so if this is large, say it's greater than or equal to 30, here also this other sample N2 greater than or equal to 30, we can invoke central limit theorem and say that the sample will behave normal. So what that means is our estimator, so if x1 bar behaves like the sample 1 behaves normal and sample 2 behaves normal, that means my x1 bar minus x2 bar will also behave normal. So it will have a normal distribution. So if that is the case, then we will have the standard deviation of the difference of the mean. So standard deviation of the difference of the mean, so that is represented by sigma x1 bar minus x2 bar. So this is the standard deviation of the difference of the means, is represented by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So this means if we have a population standard deviation which is sigma 1, and for population 2 sigma 2, these two should be known because we are using them. Those two should be known. So even if we don't know and the sample size is large enough, like greater than 30, we can substitute sigma 1 with S1 and sigma 2 with S2. So that's mostly the idea behind using z-stat. So one of the important things in this is in z-stat is both the samples n1 greater than 30 and n2 greater than 30, and sigma 1, which is samples which is population standard deviation, and sigma 2 are known. So these are the important things to use z-stat. So we will try to do hypothesis testing, how to do hypothesis testing, and how to do confidence interval using z-stat. So for hypothesis testing, the first step would be to define the hypothesis. So the statistical definition of defining hypothesis, the null hypothesis H null, would be mu1 minus mu2 is equal to 0. So this is the first case. So the alternative for this would be mu1 minus mu2 not equal to 0. So this is a two-tailed test, because it's directionless, and we can kind of disprove the null hypothesis on both sides. And then we have H null, which is mu1 minus mu2 less than or equal to 0. The alternative for this would be mu1 minus mu2 greater than 0. The third situation would be H null, mu1 minus mu2 greater than or equal to 0. So the alternative for this would be mu1 minus mu2 less than 0. So if you see, these two are one-tailed test because we can test only on one side. So the next step of a hypothesis test would be to compare test statistic with critical value So test statistic, to use z-stat, we should have n1. So both our samples should be greater than or equal to 30 to make the difference in the means normal distribution using central limit theorem. N2 should be greater than 30. And then sigma 1, sigma 2 are known. So these conditions should be fulfilled in order to use z-stat. Then our z-stat formula would be x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. Again, this is the estimator for the difference in the mean. This is the hypothesized difference. This is standard error. So it's a standard error of the difference of the means. So critical value, you might know, we get this from a z table. It can be z alpha over 2 if it is a two-tail test. And z alpha if it is one tail test. And then we finally make based on our test comparison, we make conclusions. So the other thing is the confidence interval, which is 1 minus alpha percent confidence interval. So the formula, alpha is the significance level, you might know this. So the formula for this would be x1 bar minus x2 bar plus or minus z alpha over 2 square root of sigma 1 square by n1 plus sigma 2 square by n2. So again, we have this as an estimator. This is the critical value. This is the standard error. So this would be the standard error, and this whole thing is margin of error. So now that we know the concept of hypothesis testing and confidence interval, we will try to solve some problems in this by using ZStat. Suppose I am interested in comparing the ticket time for McDonald's and Taco Bell. So I'm saying the ticket time is different. And I'm trying to prove at 95% confidence interval. So confidence interval, I will try to write CI. So the first step is to define our hypothesis. So our null hypothesis, H null, would be both McDonald's and Taco Bell have same ticket times. So that is mu1 is equal to mu2. So I'm considering McDonald's as population 1. So this is population 1. So I will just write P1, and this is Taco Bell is population 2 P2. So our null hypothesis is both are equal. The ticket times of McDonald's and Taco Bell are equal. So this can also be written as mu1 minus mu2 equal to 0. So our alternative would be mu1 minus mu1 not equal to mu2. So that is mu1 minus mu2 not equal to 0. So because those two are populations, now we can take a sample to test our hypothesis. So our sample for McDonald's is represented by sample 1, and suppose the mean of sample 1, which is McDonald's x1 bar, I get the ticket time of 5 minutes with the standard deviation sigma 1, which is known. So this is population standard deviation is known, which is given by 0.5, and the sample size n1 is given by 36. So we took 36 data points, and our average ticket time for McDonald's was 5 minutes with known standard deviation of the population 0.5. So for Taco Bell, our x2 bar, which is the average ticket time for Taco Bell, would be 4 minutes, and the standard deviation is known and is given by is 1 minute, and the sample size is 49. Since our both n1 and n1 is greater than 30, n2 is greater than 30, sigma 1, sigma 2 are known, we can apply Z stat. So the next step is to compare test stat statistics with critical value. So our test stat formula is Z is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. So if we substitute those values which we got, so this will be in our in our problems, this will be given. So once we substitute, so our x1 bar is 5, our x2 bar is 4, and then mu1 minus mu2, if you see that it's a hypothesized difference, so the hypothesized difference is 0. So that's 0 divided by sigma 1 square is 0.5 square divided by n1 is 36 plus 1 square is sigma 2 square divided by 49. So the Z value which we obtain will be 1 divided by 0.165386, which is 6.04. So now we have to compare this with the 6.04 with the critical value. So the critical value, our test is a two-tailed test. If you see, it's directionless because we can disprove the null hypothesis on both sides of a normal distribution curve. So the critical value would be Z alpha over 2. So to get Z alpha over 2, the first thing is we are given a confidence interval of 95%. So 1 minus alpha is 0.95. So alpha would be 0.05 and alpha over 2 is 0.025. So we need a value of z 0.025. So we can try to understand this by using a normal distribution curve. So if we have a normal distribution for the difference in the mean, so it is representing the difference in the mean. So this is a curve of null hypothesis. So this would be 0, as we know mu1 minus mu2. This is mu1 minus mu2, or a sampling distribution of the sampling distribution of the samples. So we are looking for our null hypothesis. We are saying 95% confidence interval. So if we have this, and this area is 95%, suppose 0.95. So in this region, we say do not reject null hypothesis. Null hypothesis would be true in this region. So do not reject H null. However, if you see this region and this region, we reject H null. So based on our critical value, this is 0.025 and this is 0.025. So we need to calculate z value here and here. So our z table, as you might know, we have to go to our z table and it only gives us the left hand side. So our z table always gives us left hand side. So that is, if we have a normal curve like this, the one which we are using will tell the z value only towards the left side. So the better option here would be to look for z value, this z value. So I will go to a z table and look for z 0.025. So here is my z table. So I can go and look for 0.025. Hmm, 0.025 is 0.025. So here is my 0.025. So my z value would be negative. So that would be, let me highlight it, 1.96. So my z value would be negative 1.96. So I will go to my sheet, and this is negative 1.96 negative 1.96. So this will be positive 1.96. So now I am comparing my critical value with my z stat value. So 6.07, where does it lie? So here I have a z value of positive 1.96. So my 6.04 will lie towards the right. So somewhere here I will have 6.04, suppose. It falls in the rejection region, so we will say reject H null. So if we reject H null, which is both are equal, our claim is true. Ticket time, so we are kind of saying this might be true. So our claim ticket time is different is true. So this is how you solve a two sample hypothesis testing. Let's do for the same problem the confidence interval. Let's calculate the confidence interval for the same problem. So 1 minus alpha multiplied by 100% confidence interval. The formula is x1 bar minus x2 bar plus or minus z alpha over 2 sigma 1 square by n1 plus sigma 2 square by n2. So we know our x1 bar is 5, x2 bar is 4, and then z alpha over 2 we calculated from our z table. So if you see here, that is negative 1.96. because we are doing confidence interval, we can just take the absolute value. So this would be 1.96, and n1 sigma 1 square would be 0.5 square, n1 is 36, sigma 2 square is 1 square, and n2 is 49. So if we put all those values, 5 minus 4 plus or minus 1.96 square root of 0.5 square divided by 36 plus 1 square divided by 49 So this is going to give us 1 plus or minus 1.96 multiplied by 0.165386. So this is, the interval would be 0.675843 and 1.324157. So your mu1 minus mu2, the difference in the mean will lie between these two values. So the lower limit of mu1 minus mu2 would be 0.675843 and the upper value would be 1.324157. So if you see, both these values are positive values. So when can this expression become positive? It can only become positive when mu1 is greater than mu1 is greater than mu2, then only our both lower limit and upper limit will be positive. So when you solve these problems, if both are positive, mu1 is greater than mu2, that means in our case McDonald's is taking more time compared to Taco Bell. So if these two values, so if both the lower limit are positive, lower limit and upper limit are positive numbers, then your mu1 is greater than mu2. If they would have been negative, so both the numbers, when can they be negative in this definition? When mu2 is greater, so that means mu1 is less than mu2. If one lower limit is negative and the upper limit is positive, so this has 0. So that means we can say mu1 is equal to mu2. So in this case, if you see, we have both positive, that means McDonald's has a higher value compared to Taco Bell. That means McDonald's is taking more time to deliver a product to you compared to Taco Bell. So that's a two-tailed test. We can solve one more problem and see whether we understand hypothesis testing. So I have a statistics class. So I have section 1 and section 2, and I doubt that section 1 has students. Section 1 students has less weight compared to section 2. So that means I am claiming if section 1 the population mean is mu1, if this is mu1, I am claiming mu1 is less than mu2. So the first step of a hypothesis testing is to define null hypothesis. So I can say mu1 greater than or equal to is my null hypothesis, or mu1 minus mu2 greater than or equal to 0. My alternative would be H alternative mu1 less than mu2. So this is mu1 minus mu2 should be less than 0. So again this will be given, so we conduct an experiment and take some samples and get the statistic values. So this will be given in your problems. So for my section 1 I took a sample of suppose n1 is equal to 64, and then I got a mean of x1 bar, mean weight of 164, and and then I have sigma 1, which is again sigma is known, is 3, and for my sample 2 I take again a 64 students and I get the average weight or the mean of 180 pounds, and then my sigma 2, which is again standard deviation is known, and it's 4, and I'm using a 95% confidence interval. So the next step is to compare test statistic with critical value. So test statistic, again what stat to use? N is 64, n1 is 64, so n1 is greater than 30, n2 is 64, it's also greater than 30, and sigma 1 sigma 2 are known, so we will use a z stat. So the formula for z stat is given by z is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So we can substitute those values here. our x1 bar is 164 minus x2 bar is 180 minus the hypothesized mean. Again, the hypothesized mean is 0, and then square root of sigma 1 square is 3 square divided by 64 plus 4 square divided by 64. So we will get a value of negative 25.6. So this is our test statistic value. So to get critical value, again I will go to our table, but now we have to determine whether that it's a one tail or a two tail. So our problem is mu1, so we are doing a directional test, mu1 minus mu2, mu1 is less than mu2 or mu1 minus mu2 less than 0. So it's a directional test, so it's a one tail test. So for one tail, okay, this is tail. So we are looking for z alpha value, that is alpha. If you see 1 minus alpha is 0.95, alpha would be 0.05. So I'm looking for a value z 0.05. So if we again draw our normal distribution curve, we have a normal distribution curve, and this is our null hypothesis. So this is our null hypothesis. So because we have a greater than or equal to 0, we will have a value, and anything above this, so anything to the right is do not reject H null. So anything to the left, so this whole area we reject H null. So this whole thing here is 0.05. So we are looking for a critical value, z value here. So that would be, we have to go and look for 0.05 in our z table. So I will go to our z table and look for 0.05. So 0.05, if you see, it's somewhere here or here. So maybe I will highlight it with some different color, maybe blue, this and this. So the z value would be negative 1 point. So that's z value, so I will just highlight that with blue also. Negative 1.64 or 65. So negative 1.64 or 65. I can take one of those. So I will go to my sheet. So this is negative negative 1.64. So if you see our z stat value, so it will lie negative, because this is negative somewhere here would be negative 25.6. so it's in the rejection region, so we reject H null. So when we reject H null, if you see, I'm claiming reject H null, so this is not true. So mu1 minus mu2 greater than or equal to 2 equal to 0 is not true. That means mu1 should be less than mu2. So our claim section 1 students has less weight compared to section 2 is true. So this concludes our lecture on comparison of two means with known variance, that is Z stat. Thank you.